All right, so we want to evaluate the definite integral here and using method 2, which means we're not going to substitute back. All right, so first of all, what is u? Oh, wait, this is, oh, I'm sorry. This is not that problem. Well, it sort of is, but it's identical. We had done this problem yesterday. We had started it. So let's just take that information. Remember, we had to use the creative substitution to solve and replace for x, right? Because this is not just a chain rule. So we're kind of using this creatively. Oops, did you not want to do that? So we will cut and move this over here. So let's just look at how this problem would be different if we use method 2. We'd already have done everything else. All right, so we did that nice little, we had to rewrite this. We had to replace the x. So this is not a true chain rule. And so we replaced the x by taking our u expression and solving for x. You can you do that when you've got like this under a radical, you've got a radical expression and you've got an x. Because if it was just an x and not a radical expression, you would just distribute. And the problem with distributing is you've got a binomial and it's raised to a power. So you can't go in, the exponent precedes is more powerful than the multiplication, right? Exponents before multiplication. So we can't take something, we can't multiply the x into the 4 or into the x to the dx because of this, the radical. But if I rewrite this so that I have a single term there, then it's not a problem because now I'm just distributing the single term. I'm going the other way. And the other thing was not in a radical. So we had u equals 4 minus x. du is going to be negative dx. There is no negative, so negative du is dx. Since u is 4 minus x, we need to rewrite that x there. That's the problem, and we can't simplify it the way it is in terms of u's. So I solve for x here. So x is equal to negative u plus 4. So we're going to replace that x with a negative u plus 4. And that's where we began with the last problem. So under the radical here, we would have the negative u plus 4 times u to the 1/2 power du. And we had the negative outside here, all right, because of the negative du. So I can multiply a single term raised to a rational exponent to a binomial that has no exponent on it. I just couldn't do the reverse. I can't distribute the x to these guys with the exponent on them. All right, so now when we rewrite this, this becomes negative. The integral of this becomes negative u to the 3/2 plus 4u to the 1/2 du. How this problem will differ from the other problem is that now we're not going to substitute back. We're going to get new limits. So now all we do is we plug in the 0 and the negative 5 in for u. All right, so we take, since u is 4 minus x, right, so then 0 is going to be 4 minus 0, or 4. And negative 5 will be 4 minus a negative 5, or 9. So now we're not going to substitute back. We've got new limits now. And so this is going to be 4 and 9. Right? So now we'll integrate. We have u to the 5/2, negative u to the 5/2, and we have to multiply by the reciprocal because we're dividing by 5/2. So that would be 2/5. And let me just kind of throw the negative in front of the 2/5. Everyone okay with that? Looks nicer. Negative 2/5 u to the 5/2, and then don't forget there's a negative outside this whole thing that we have to distribute. And then plus 4u to the 3/2 times 2/3. And we'll evaluate that from 4 to 9. So we'll clean that up and then distribute the negative. This is going to be 2/5 u to the 5/2. This will be minus, and it'll be 8/3 minus 8/3 u to the 3/2 evaluated from 4 to 9. Now I'll just plug in the values. So we have 2/5. I'm going to rewrite this as a square root. Square root of 9 to the 5th power minus 8/3 square root of 4 cubed, which will give us 2/5 times, this would be 3 to the 5th power, which is 243, minus, so this would be 2 cubed, so that's going to be minus 64/3. Well, I'll write in 8/3. And then this would be 2 cubed times 8. So that's going to be, if I can stretch this microphone, I'll just extend the page. Oops, extend the page. Go. So this is going to be 400, oh, we don't have a common denominator, of course. So this is going to be 486 fifths minus 64 thirds, which we'll have to change that to 15ths. So 486 times 3, real quick.
400.
Yeah, I'm going to get real quick.
1400, like
1458.
1458. And then, so now this is going to be 15ths. So times 5, that would be 320. So that's going to give us 138 fifteenths. Did I?
Does that simplify? Because there's what's an 8?
No. No, I don't think so. It's not divisible by 5, and it's not divisible by 3. So the answer is no. Because that'd be 11, 12, 13, not divisible by 3. So 1138 fifteenths. Did I? Any mistakes on my math there?
Are we supposed to plug in twice, not just into the one?
Oh my gosh, what did I do? I'm sorry. Don't watch this, Dylan.
Specifically Dylan. Everybody else can.
Hi, Dylan.
You're all erasing that. Oh my gosh, I'm
I
sorry.
just wrote all that work down.
Oh, silly me. Oh, silly me. Oh, awful. Okay, well, there's wrong. There's wrong. Everything I have to plug in the 9. We have 2 terms. Oh, silly me. We have 2 terms. Plug in the 9, then plug in the 4. I should probably retape this. All right, so
I just love him suffer.
Oh, don't watch that.
it's contaminated. Oh my gosh. Maybe I need rest. All right, let's
We should have
clean this up, distribute, and do this right this time. And let's change colors so that you can actually see the plug here. So here's the evaluating. Oh my gosh. All right, so 2/5 u to the 5/2 minus, because they're distributing the negative, 8/3 to the 3/2. We should have 4 terms because we got to plug in the 9 to both of them and the 4 to both of them. There's 2 terms there. Oh gosh, silly me. Silly me. All right, so 2/5
I don't know where to go back.
times, just erase it all, 9 to the 5th power minus 8/3 square root of 9 cubed. All of this, gosh, that's the worst evaluating I've ever done in my life. All of this, you have to add in the 4s and subtract. Of course, I'm taping
I
it.
thought way worse.
Oh my gosh, I'm so embarrassed. All right, so 2/5 square root of 4 to the 5th power minus 8/3 square root of 4 cubed. All right, now let's stop and take a moment. So it's easy to like go on automatic pilot when you plug in and just stick in the wrong values like that. So make sure you've got two values here, two values in our expression. Make sure you've evaluated them both for 9 and both for 4 and subtract the 4s from the 9s. All right, now let's clean this up. All right, square root of 9 would be 3. 3 to the 5th power is 243 multiplied by 2/5. So 2/5 times 243 minus this would be 27 times 8. No, we can reduce that. So 72. All right, because that'd be 27 times 8 thirds. 3 goes into 20 to the 27 9 times, so it's 9 times 8. 8 times 9. And then minus, so this will be a negative. This is going to be 2 fifths. And then square root of 4 is 2. 2 to the 5th is 32. Now a plus, because we're distributing the negative, 8 thirds times square root of 4 is 2. 2 cubed is 8. All right, there it looks good. Let's combine the like things first. So, and then multiply out. So this is 4, 8, 6 fifths. And then we have, I'm just going to reorganize this, minus 64 fifths. They have the same denominator. And then we have a plus of 64 thirds minus 72. We may as well subtract the 2 fifths there. So that's going to be 422 fifths plus 64 thirds minus 72. Now on the last page, on the last problem, we took those same values, hopefully the same values, there we go, and added them together before. So we know what they're going to equal, right? Let's make sure, do I have all the right negatives in all the right places? So, do we have a sign difference here? Oh no, it's the 72 that's going to make everything negative. So we have the right signs. So we know it's going to equal. What was it? What did it equal from yesterday?
108.
All right, so the final answer was negative 506/15, right? Because these are the exact same number. Why do we have a different sign?
I thought it was 12, 15, 1,215 over 8.
Why is the signs on the numbers look different to me? Add up these numbers real quick, the numbers that are right there.
422 plus 64
Minus 72.
I'm going to have to watch the podcast.
I don't see a sign error here.
Future Cole, drop out.
No,
So the top is 558.
Get it right.
So what is this when we add this up? The 422 fifths, the 64 thirds, and the negative 72.
Ooh. Future
64.
Cole. You should have split for dinner.
Let's get some pierogies.
Stop.
506 over 15.
Positive or negative?
Positive.
Positive. All right, we have a sign difference here. One of those is correct. Let's see which one. All right, so
Wait a minute.
I think I screwed up somewhere else. How do we end up with 72?
This is why we're behind, because we can't figure out whether or not the problems are right.
huh? Yeah.
Problems take more than like a percent.
Well, we will end this tape now, and we'll tell you where we figured it out.